Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting topic, that is integers. Now in this chapter we will learn about the introduction of integers, and we will learn about addition and subtraction of integers, how we can multiply, divide, and look at the sum property of integers. Now let's start with the introduction. Now you have already learnt about integers and their placement on the number line, like how we can place the integers on the number line and the absolute value of an integer, addition and subtraction of them. Now let us revise some important points regarding it. So the important point here is that a combined set of negative numbers, 0 and whole numbers is called an integer. For example, that is -4, -3, -2, -1, 0 and so on up to positive numbers. Now what is an absolute value of an integer? The absolute value of an integer is the numerical value of an integer regardless of its sign, and it is denoted by a magnitude. The absolute value of an integer is either positive or 0. Now here is our example. The absolute value of -5 is 5, 7 minus 8 absolute value is 1, 3 minus 3 absolute value is 0. Now always remember, the numbers 1, 2, 3, 4 are our natural numbers and the numbers 0, 1, 2, 3 are our whole numbers. Now also the corresponding positive and negative numbers have the same absolute value. For example, 9 absolute value is 9 and -9 absolute value is also 9. Now let's start with the ordering of integers. Integers and whole numbers obey the same rule in their ordering when they are represented on a number line. The integer represented to the right of any number is greater than that of that integer to the left and vice versa. Now for example, 5 is greater than 4, 7 is greater than 6, but in the negative cases, -1 is greater than -2 and -3 is greater than -4. Now from the above figure, it is clear that for every positive integer to the right of 0, there is a negative integer to the left of 0 placed at the same distance from the 0. Now 0 is greater than every negative integer and hence it is less than every positive integer. Now every positive integer is greater than that of every negative integer. Now let's look at the addition and subtraction of integers. When two integers have the same sign, either positive or negative, when they are added, we add their absolute values and we will assign the common sign to their sum. So here when we add, it becomes 44. Generally the positive sign here with the positive is not written, but negative sign is always written. Now when we add integers with the different signs, we first find the difference and then we will put the integer sign which have the greater absolute value, that is which one has a greater sign, minus. So the answer is in negative. Here which one has a greater sign? The greater sign is positive, so the answer is positive. Greater number having the sign positive, so here the answer is positive. Now while subtracting two integers, we will change the integer to be subtracted into its corresponding negative integers and then we will simplify the two integers. Now here when we simplify it, it becomes +4, 3 minus 7, that is -4, 7 minus -3, that means +3, that is 10, 3 minus -7, that means minus is plus, again 10, -7 plus 3, -4, -3 plus 7, 4, -7 minus 3, -10, -3 minus 7, that is also our -10. Now let's look at the addition of integers on the number line. Let's look at the working rules. Here are our steps. In step 1, we have to draw a number line and we will mark points as a negative integers from -1, -2, -3 and so on. Then 0 and then positive integers 1, 2, 3 and so on. Now for positive integers, we will move forward for a negative integer, move the background, and that is our result. Here in example number 1, here we have to add the following numbers on our number line. When we are adding 5 to the 3, we get 8, -3 to -4, we get -7, and when we add 5 minus 3, then we get +2. Now let's start with our exercise 1.1. In the first part, here we have to fill in the OMR sheet correctly. The first part says that 5 less than -4 is. That means 5 less than -4, that is our -9. That's how you can complete the remaining ones. Now let's start with the multiplication of integers. We have learned that multiplication is nothing but our repeated addition. So we can find the product of any two integers using the repeated addition method. Here are our example. We have to find the value of minus 3 minus 4, that is 12. On number line, when we move from 4 times in the steps of 3. Now in example number 3, here we have to find minus 3 into 4, that is our minus 12. Now minus 3 into plus 4 means we are moving to the left of 0 4 times in the steps of 3. Now here we have look at the multiplication of two negative integers. Now observe this pattern here. When we are multiplying with a negative sign, the answer is always a negative. What do you observe? That when we multiply and when the multiply decreases by 1, the product increases by 4. Using this fact, we can proceed like here when we are increasing, it is a multiple of 4. We can also proceed in the other one like this. What we have done, again we have multiplied it by the multiple of 4, but here we have find the product of two integers, that is the product of their absolute values and their signs as follows. Now here the product of two positive integers has a positive sign always. For example, 5 6 are 30, 7 4 are 28, but the product of two negative integers also has a positive sign. For example, minus 4 minus 3 12, minus 7 minus 9 63. Now the product of two integers with opposite signs have a negative sign. 8 into minus 5, that is minus 40, 6 into minus 7, that is minus 42. Now let's look at the example number 4. Here we have to find the product of the following. Minus 3 into 4, that is minus 12. 6 9s are 54, minus minus is positive, and 12 into 5 is minus 60. Now let's look at the division of integers. Now we know that for whole numbers, every multiplication fact gives us our two division facts, that is 7 9s are 63. These are our multiplication fact, and when we divide it, we get 9 and 7. These are our what? Division facts. Now let's look at example number 1. What we have said here, that minus 12 into 4, that is minus 48. 48 divided by 4 is minus 12. So when we divide it, it gives us 4. Now in the second example, what we have given, that 7 into 3 is minus 21. When we divide it by 7, we get minus 3 and 7. These are our multiplication facts. So the division fact here is 120 and the multiplication facts are minus 10 and minus 12. So from the above examples, what we have concluded? We have concluded that the division of two positive integers or two negative integers always gives us a positive quotient, but the division of a positive and a negative, or the division of a positive and a negative quotient, gives us a negative quotient. Now let's look at, we have to find the quotient of the absolute values of integers. So we will assign a positive sign, and then the quotient of both divisor and dividend have the same sign, that is either positive or negative. Now we will assign a negative sign to the quotient, that if the divisor and the dividend have opposite signs. Let us see an example. Here in example number 5, we have to determine the quotient for each of the following. So when we divide it by 8, we get minus 9. Minus 22 divided by minus 11, that gives us 2. Minus 80 divided by 10 is minus 8. 42 divided by 6 is minus 7. Now let's start with our exercise 1.2. In the first part here, we have to multiply the following: 20 and 0. So when we multiply 20 by 0, what we get? Very good, that is 0. That's how you can complete the remaining ones. Now let's look at the mental maths. Here in the first one, we have to state true or false. 0 divided by minus 7 is 0. Yes, it's a true statement. That's how you can complete the remaining ones. Now let's look at the properties of integers, and first let's look at the properties of addition. In this one, first is our closure property. Let a and b be our any two integers, and a plus b is always an integer. So this is our what? Closure property of addition of integers. For example, 8 plus 5 is 13, minus 6 and minus 6. Now commutative property. Now if a and b are two integers, then a plus b is always equals to b plus a. Now on changing the order of integers, we get the same result, and this is called the commutative property of addition of integers. For example, 6 plus 4, 10, minus 3 plus 12, that is 9, minus 8 plus minus 4, that is minus 12. Now let's look at the associative property. If a, b and c are three integers, then a plus b plus c is equals to either a plus b and then plus c. Now in the addition of integers, we get the same result even if the grouping is changed. This is called the associative property of integers. For example, minus 3 plus minus 4 and minus 7 plus 8, that both are equals to 1. Now let's look at the additive identity. If 0 is added to any integer, then the value of integer does not change. If a is an integer, then a plus 0 is equals to a. This is our 0 is our what? Additive identity of integers. For example, 12 plus 0 or minus 3 plus 0, it will always give us the same number. Now let's look at the additive inverse. When an integer is added to its opposite, we get the same result as 0. That means if a is our integer and minus a is our what? Opposite or vice versa of it. So what we will get? We will get 0 as our answer. Thus an integer and its opposite sign are called, they are called the additive inverse of each other. Here our example, that when we add the pair of integers like 9 minus 9, 15 minus 15, these are our what? Additive inverse of each other. That means they will get our answer as 0. Now let's look at the property of 1. Addition of 1 to any integers gives us what? Its successor. For example, 12 plus 1 gives us 13. Minus 5 plus 1 gives us minus 4. So minus 4 is what? It is the successor of minus 5. Now let's look at the properties of subtraction. First one is our closure property. If a and b are two integers, then a minus b will always be what? Integer. So this is our property of subtraction of integers and closure. For example, 9 minus 3 minus 4 minus 13 minus 11 are what? Integers. Now next is our commutative property. What commutative property says is that if a and b are our two integers, then a minus b need not be equals to b minus a. That means 7 plus 8 is 15, but minus 8 minus 7 is minus 15, and both are not same. So subtraction of integers is not commutative. Now next is our associative property. What it says that if a, b and c are our three integers, then a minus b minus c need not be equals to a minus b minus c. That means if we change the order of the subtraction, it will also change our answer. For example, here in this one, the answer is 2, but in this one, the answer is 6, and both are not equal. That means our subtraction of integers is not associative. Next is our property of 0. When 0 is subtracted from an integer, we get the same integer, that is a minus 0, where a is what? A is an integer. So 12 minus 0 is 12, but here it is minus 12 and minus 23. So it satisfies our property of 0. Next is our property of 1. Property of 1 is subtraction of 1 from any integer gives us what? Its predecessor. For example, when we subtract 1, we get the predecessor. When we subtract the 1, we get the predecessor, again the predecessor. Now, properties of multiplication, closure property. If a and b are two integers and when we multiply them, it will also be our what? Integer. So this is called the closure property of multiplication. Here 7 into minus 5 minus 35, 18 and minus 15. Commutative property. Now if a and b are two integers and a into b is equals to what? B into a. Now on changing the order of integers, what we will get? We will get the same result. This is our what? Commutative property. For example, when we change the order, the answer is the same. When we change the order, the product we always get is same. So that means commutative property holds good for multiplication of integers. Now next is our what? Associative property. Now if a, b and c are three integers, then a, b into c is what? When we change the order, the associativity property remains hold. For example, here when we change the order, and here again when we changes the order, the answer we get is same. That means associative property is true for multiplication of integers. Now next is our multiplicative identity. Now what our multiplicative identity says that if the product of any integer and 1 is our what? It will get our same integer. For example, a into 1 is equals to 1, that is equals to 1 into a, and 1 is our what? The multiplicative identity. For example, when we multiplied it, we get the same number, again we get the same number. Now next is our multiplicative inverse. Now the product of any integer and its reciprocal, it gives us the same result as multiplicative identity. So if a is an integer, then a into 1 by a is equals to 1, that is equals to 1 by a into a. So an integer and a reciprocal are what? They are called the multiplicative inverse of each other. For example, when we multiply by same number, we get 1, again we get 1. Now let's look at the property of 0. Now what our property of 0 says that the product of any integer and 0 gives us the same result as 0, and if a is an integer then a into 0 is equals to 0 into a. Now here is our example that when any number is multiplied by 0, the answer is always 0. Now next is our what? The distributive property. It says that multiplication distributes over addition. That means if a, b and c are our three integers, then a into b plus c is equals to ab plus ac. This is our what? Distributive property of multiplication of integers. For example, when we applied the left hand side and then the right hand side of the formula, we get our same answer, that is 7. So that means it holds true for distributive property of multiplication. Now next is our properties of division. Let's look at the closure property. Closure property does not hold good for division of integers. Why? Because when we divide, 3 is an integer, minus 5 is also an integer, but 9 by 4 is not an integer and half also not an integer. So that means when we divide, first and second are the quotient of two integers is integer, but when we look at the third and the fourth case, these are not integers. So that means the closure property does not hold for division of integers. Now next is our commutative property. Now if a and b are two integers, then a divided by b is not equals to b divided by a. Why? Because here 4 divided by 2 is 2, but 2 divided by 4 is half. 3 minus 3 divided by 1 is minus 3, but when we divide it by this, then we get minus 1 by 3. So here what we see that the order of integer is changed and the result does not remain the same. Hence, integer does not possess commutative property of division. Now next is our associative property. Now if a, b and c are our three integers, then a divided by b divided by c is not equals to the other order. That means when we divide it according to the left and according to the right hand side, minus 3 is not equals to minus 12. So that means associative property is not good for division of integers. Now property of 1. Now any integer divided by 1 gives us the same integer as the quotient. So if a is an integer, a divided by 1 is a. For example, 5 divided by 1, 5, 28 divided by 1 is minus 28. Next is our property of 0. What it says that when a 0 is divided by any integer, the result will always be our what? It will always be 0. For example, 0 divided by 9, 0, 0 and again 0. Always remember, division of integers by 0 can never be defined. You can never define any division of integer by 0. Now let's look at example number 6. Here we have to find out the answer of this by two methods. Now you have to tell me which way is easier. First method is when you multiply it directly, and second method is when we multiply it by the 25 and then by 4. So we can see that our first method is easier, as 25 into 4 is what? 100, and then we can directly add 2 zeros to it. Now next is our example number 7. Here we have to simplify it. So first what we will do? Firstly, we simplified. We took 125 common and then we add all these terms and then we multiplied it by 30. Now example number 8, here we have to multiply this by 105 using the distributive property. So what we can write 105 as 100 plus 5. So after writing it as 100 plus 5, we put the distributive property of multiplication and then this is our required answer. Now let's start with our exercise 1.3. Here we have to fill in the blanks. Minus 35 divided by 35 is what? Minus 1. That's how you can complete the remaining ones. Now let's look at the chapter end exercise. Here we have to take the correct option. Every natural number is also very good. A and B both, that is an integer, also a whole number. That's how you have to complete the remaining ones. Now here's our mental math. We have to verify this property where A, B and C have given to you. So when you verify it, what will be your A? A is minus 3 into 7 minus 9. That is 7 minus 9 is minus 2. And minus 2 into minus 3 is what? 6. And when you apply it on the right hand side, 6 is your answer. That's how you can solve the remaining ones. Now next is our horse. In the first one, you have to tell me what will be the sign of resultant integer if we multiply minus negative 5 integer and 2 positive integers. That means when you multiply 5 negative integers, that is minus 1, minus 2, minus 3, minus 4 and minus 5 multiplied by 2 and 3, the answer sign will be negative. Now here is our assertion and reasoning that you have to solve it by yourself, students. Now I hope you have understood this chapter pretty well. You just have to practice the exercise question and don't forget to revise this topic again.